Hi friends, welcome back. So today we will see another video that is on prediction of the type of the breast cancer using kNN, right? So this is what we will do the analysis using machine learning algorithm, that is kNN, in the breast cancer. So let's first import the libraries. So we are going to import all the necessary library to plot graphs and all these things inside our Jupyter notebook. So again, matplotlib, numpy, pandas, right, sklearn.model selection to split our data into train test, then sklearn.neighbors to apply the k neighbors classifiers, right, and then z-score to get the z-score from the stats, and SNS for visualization and plot for plottings. Now load and review data. So first we will load the CSV. The link I'll be providing in the description also, and we are getting the shape of BC data, so that is 569 by 32. Then we are getting the data type of all the columns inside our variable or the data set. So you can see that most of them are of float type, and we have diagnosis that is of object and ID is of integer. Next is we are getting the type, or we are telling that okay, in the diagnosis that is currently our object, and we are telling that just convert it into a category, right? So bc data dot diagnosis dot as type as category. So if you see that describe, right, so in the describe we are also getting the transpose. Okay, so here you can see that after transposing we are getting the count, mean, standard deviation, minimum, or the interquartile range we can say, and the transpose or the all the values, right? So here you can see that condition, let's say the connectivity mean, and that is for count, that is for mean, standard deviation, minimum 25th percentile, 50th percentile, 75th, or the maximum. Now we are counting the diagnosis type. Okay, so what it will do is it is telling that class distribution among B and M is almost 2:1. The model will better predict B and M. So B and M is nothing but a type of diagnosis. So here you can see that B is this one and M is this one, right? So now we are dropping the first column from the data frame, and this is ID column basically, which is not in our use. So what we will do is we will drop the column that is ID, and axis 1 is deleting that permanently. So what the comment is also saying, the first column is ID column, which is patient ID and nothing to do with the model attribute, so just dropping it. Now after dropping it we get the shape that is 569 by 31, and we create a separate data frame consisting only of the features, that is independent attribute. Okay, so here xy we have x, we have bc data dot drop, labels we have diagnosis x is equals to 1, y that is bc data, that is diagnosis, and x dot head. So here you can see that now if we get the x dot head, so we will get the top 5 rows of the data set, right? And here you can see that x is containing our what, except diagnosis, like all the columns. So you can see that it is containing all the columns of our data set except diagnosis for the train test split. Now converting the feature into z-score, as we do not know what unit or scales were used, and store them in new data frame. So it is always advised to scale numeric attributes in modules that calculate distances. So here you can see that x scaled is nothing but x dot apply z-score, which will convert all attributes to z-scale, and x scaled dot describe. So after x scaled dot describe, it will give us all these values, right? So the describe function as always do the all the count, minimum, standard deviation, min value, max value, interquartile ranges, right? Now the next step is to split x and y into training and test set. So here we are doing with 75th by 25 ratio. So no, it is not 25 ratio, it is by 30 and 70 ratio, right? So here x train x test, y train y test. So train test split, we are passing that x scaled y, and the size of test size is our 30%, right, and random state is 1. So now building the kNN model. So NNH, that is k neighbor classifier, n neighbor equals to 5 and weight equals to distance, right. Now calling the nearest neighbor algorithm. So nnh dot fit equals to x train y train, and here you can see that k neighbors classifier, that is algorithm, we are giving auto, leaf size 30, matrix Minkowski, matrix params none, n jobs none, n neighbors 5, p equals to 2, and weights equals to distance. Now finally evaluating the performance of kNN model that we have applied. So for every test data point, predict its label based on 5 nearest neighbor in model, right. The majority class will be assigned to the test data point. Okay, so here predicted labels will be nns.predict xtest and nns.score xtest and ytest, so which will be our 96%. Now calculate accuracy measures and confusion matrix. So here you can see that we are importing matrix from SL9, and the confusion matrix we will be again getting the true false, true negative, false positive and false negative value. So what we are doing is in dfcm we are telling that okay, in pd.dataframe just take the cm that we got the confusion matrix, iterating that with every m and b attributes, right, which will predict m and predict b, right, and splitting that figure into 7 by 5th. So if we get the heat map, so you can see that the bm, right, and the predicted m and predicted b. So this way you can assume that okay, the breast cancer ratio, what was predicted and what was the actual value, right. And now yeah, this is another notebook where everything is same, but what I have tested is with choosing the k value. So basically how we can choose the k value, there are mainly we recommend two way to get the k value. One is to do the square root of n, right, and another is using an odd value. So let's say choosing the right k is not easy and is subjective, but usually choose an odd number is chosen, right. A small k capture too much training noise and hence does not do well in test data. So a very large k does so much smoothing that it does not manage to capture information in the training data sufficiently, and hence does not do well in test data. So if the number of classes is 2, so many suggestion, a rule of thumb that approaches is set k as square root of n, right. So that might not be the best but does well most of the cases. Okay, so similarly what we have done is for k in range 1 to 50, we are getting the k neighbor classifier in NNH and passing the n neighbors, that is k, right, and weight is distance, and we are trying to fit the model and with the k neighbor classifier and passing the x train y train, and we are getting the score dot append, right, and telling that okay, the classified score for x test and y test, and finally we are plotting the score. So here you can see the accuracy or the score after applying the k neighbor classifiers. Okay, yeah, so this was all about this video, so we'll meet in the next video. Stay tuned. All the best. Thanks.